This is part 5 in a series of videos in which I'm attempting to repair and boot this Mimi 802 vintage computer. In the previous video I got as far as successfully reading a sector from the floppy drive, so that resolved an issue I was having with the floppy drive control system. So I can now successfully read a full sector from the drive, and hence from the disk that we are assuming is a boot disk for this machine. However, the machine still won't boot. It still comes up with an error once it's read the sector. And so the next stage was to go back to the code, start going through this and try to figure out exactly what's going on. So I won't bore you by going through all this again, but this first section is responsible for reading the sector from the floppy drive. And at the end of this section there's a jump to another block of code if the sector has been successfully read, and that's what we're going to look at in this video, is to see why that section is not succeeding the way it should. So this section just loops around, reads 512 bytes of data from the floppy disk, and then if that read was successful it jumps through to another block of code which we'll now take a look at. So this is the block of code that the machine jumps to once it's read the sector, and I'll go through this in a bit of detail. I won't go into it in too much detail, it'll make the video too long and boring, but what I do is I go through the code and then I annotate it, so I put these comments on to make it more readable. If you're not familiar with doing this sort of thing, then you find it easier if you look for key instructions. And so, for example, this top block that I've separated, the key here is this LDIR instruction. Again, the Z80 has some very powerful instructions, and it's a very good machine for this type of application because it has some very powerful data movement instructions, and that's what the LDIR instruction is. It takes, as it says here, we load the BC register, so these registers are internal to the Z80. It loads the BC register with a count of bytes, and that is the number of bytes that we want to move, and then it loads the DE register with a destination address, it loads the HL register with a source address, and then the instruction, single instruction, will repeat a copy the number of times that we've indicated in the BC register. So in this case what it's doing, it's moving 80 bytes, 80 hex bytes that we copied or read from the floppy drive. It's copying those from the location that they were saved to during the read, and it's copying those 80 bytes to memory location starting at 0. So almost certainly this is a second stage bootloader. The entire operating system of course won't be in a single sector. So what's most likely happening here is it's reading the first sector, it's reading 512 bytes because that's the smallest block of code that you can read from the floppy drive because of the way the floppy drive control system works. But it only wants the first 80 hex bytes. It then copies those 80 bytes to memory location 0, and then as you can see further down it jumps to that address, which presumably starts up the second stage bootloader. Now before it gets there it runs through a few checks. So the first thing it does is it loads HL with the address 0, which is where we've copied this data to. It loads DE with the value of F120H, and it then loads the B register with a value of 4. And what this is for is, if we can go further down, look for another key instruction, we have this CP instruction. And what all this is doing is it's comparing the value in the A register with the value in memory address pointed to by the HL register. So what we're doing is we're loading A with the value pointed to by DE, and then we're comparing that value with the value pointed to by HL. HL, remember, is pointing to the first byte that we've copied into the second stage bootloader. Now these values at 0F120H are down here, So you can see the first value is 3E, the next value is 09. The disassemblers identified it as code, but it's in fact some data bytes, and there's obviously 2 more on the next page. And it's looking for the first 4 data byte values that it's read from the floppy drive. If any of these do not match what it's read, then it throws an error and aborts the boot sequence. And so what we'll do is we'll get the analyzer going, we'll trigger on this memory location, and we'll see what's going on and why the boot is not succeeding. So looking at the analyzer screen, I've got the trigger set to FOFE, which will take us to this address. Again, I've used 1 higher than the address that we're really aiming for, and that's just to make sure we don't hit this address when this instruction is executed, because the Z80 will preload the next instruction, so it might load this and trigger the analyzer when we don't want it to. So what we'll do now is we'll start up the MIMI and see if we do actually get to this address. So set the analyzer to run. I'll boot up the MIMI, and you can see after it's read the sector, we jump to this memory location, which is FOFE. So we are now at this point, and as you can see, it's read 0, 1 followed by 80, which are the first 2 bytes that we were expecting. And what it should do here is cycle through and start copying the data bytes that we read from the first sector of the floppy disk. If you can't remember what they were, this was on my high-tech listing here. So we're looking for 3E, 61, D3 and 03. So if I start scrolling across through this instruction, then the LDIR instruction is actually at address F106. So we'll keep going across till we find that address. The address we're looking at is in the lower yellow trace at the top, and 106 is what we found. So we're now at this instruction. It's ED followed by B0, so ED B0, that's the instruction we're looking for. And then when that executes, the first value it reads is 3E. So looking back at our list, we can see 3E is correct, so it is indeed copying the correct data. And also notice the address it's copying it to is 0, which again is correct. The next value should be 61. Again, a data value of 61, and the address it's copying it to is 01. So a very powerful instruction in the Z80. It does all the incrementing of the pointers, copies the data, and it repeats as many times as we've told it to. Next value we're looking for is D3. Again, D3 copied to address 02. And then just the final one we'll check here is 03, and that should of course be copied to address 3. So 03 is indeed copied to address 3. So we know it's copying the correct data, we know it's copying it to the correct location, so we know that this first part of this block of code is doing what it's supposed to. So the next thing to look at is what follows on after this. And so once it's copied this data, it does all that copying in just these 4 instructions. The next thing it does is to load the 2 pointers for carrying out the comparison of the first 4 bytes that it's just copied. So if we run down to, I'll reprogram the analyzer and we'll re-trigger the MIMI. I don't want to go through all 512 bytes or 80 hex bytes. And we'll trigger down on this section. So I'll get it to trigger where it's doing the comparison. So that's on F111. So we'll change the trigger point. On the analyzer, and I'll reboot the MIMI so that we re-trigger. And as you can see, we've triggered on F111, so we are getting down to this point. And what we're doing here is doing a comparison. If the comparison succeeds, it increments the pointers loops back round and compares the next byte, and it does that until it's counted down all 4 bytes. But if it fails, it will jump to a different address. So we'll follow it through and see where it goes to. We should be going from 111, 112, 113. So we're getting 112, 113 and 114. So we're down here. If we get down here, then we know the comparison succeeded. And we are indeed at 114, 115. So the first byte was fine. So in other words, the 3E we were expecting does indeed match the 3E that we read from the floppy disk. So we'll go around the loop. It should now loop us back to the next byte to check, which is the loop beginning at F110. And indeed it does loop us back to F110. And now we go down, and again we should be ending up at F114 if the next byte matches. So here it's going to compare 09, and as you can see it's loaded the value of 09, and it's going to compare that with the value 61, which is what it's doing here. 61 of course being the value that we read from the floppy drive. Now of course 61 and 09 are not the same. So very strong suspicion here we're going to fail, and indeed we haven't gone to F114. So previously we went 113, 114, but notice now we have branched to this address F11B, and it will continue on from there. And what this does is it jumps to an abort routine, and that's where the error is displayed on the screen that we were seeing. So in other words, it's failing in this loop because the first 4 bytes that it's read don't match what the MIMI is expecting. It's not an error in reading the disk. The data bytes on the disk exactly match what it's actually reading. So it looks like there's an issue with the disk not matching this machine. But just to be sure, what I've done is I've created a ROM in which I've replaced the 4 bytes it's looking at. So those 2 bytes, I'll just flip over the page, there are 2 more bytes on the next page, and I've replaced those 4 bytes so they actually match what is being read from the floppy disk. And I've created a ROM with that modification. I'll just pop it into the MIMI and then we'll reboot and see what happens. Okay, so got the ROM, I'll pop that into the machine. So that's now fitted, and what we'll do now is the same test, but to save a bit of time I suspect we're going to succeed on this occasion, and so I'm going to program in the address of F118. I'll actually put in F119. On the analyzer, and I'll now turn on the MIMI, and as you can see this time we have succeeded in passing this part of the test. However, I suspect this is not a solution. This was just a proof of concept to see if this is why it was failing, and if I point the camera at the monitor screen you'll see what the problem now is. So as you can see, the machine's not at all happy. It's loading the sector, jumping to the bootloader, trying to start up the machine, it's crashing, and then the entire process is repeating. I'll just swing the camera around so you can see the scope, and as you can see it is just continuously now reading sectors, or the same sector off the disk. It's trying to get the bootloader to operate, but it's crashing. So it looks like this is a problem with the data on the actual floppy disk, and I have compared that 4-byte sequence that the MIMI is looking for, scanned all the disk images, and that sequence does not appear in those disk images. So it looks like we still have some work to do to figure out what these disk images are, and to see if we can use them to boot this machine. So in the next video, hopefully we'll have some progress on how to get this machine to boot. Any ideas or suggestions are welcome.